to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Sweden's very own Adam Tornhill, who is the founder of Empear, a software services company. Adam is also the author of the books Your Code as a Crime Scene and more recently, Software Design X-Rays, which were both released by Pragmatic Programmers. Adam Tornhill, welcome to Maintainable.
Thank you. An honor to be here.
So given your experience in the industry, what do you believe are a few common traits of maintainable software?
So I would say there are at least three different things that I always look for. The first is that I like to see the whole software solution, including the code, optimized for understanding. Because after all, that's what we spend most of our time as developers doing, understanding the existing code. The second thing I look for is an alignment between the architecture, the team boundaries, and the way the system evolves. So the question I would like to answer there, are we working with or against the architecture? That's really important. And the third and final thing, I would like to have the capability to deliver at any time with unknown quality. So that's three things.
You said team boundaries and aligning with or against the architecture. What do you mean by that?
So it's actually two different things. So let's start with the first, with the team boundaries. Making a reference to Conway's Law. What I like to see ideally is that the teams carry a meaning from an architectural perspective. Because what you really want to avoid is having multiple teams work on the same parts of the code, but for different reasons. Because there's a very high correlation to quality issues that way. And it makes it really hard for individuals to maintain a mental model of what the system looks like. So that's one aspect of it.
And then there's a lot of teams out there that are software organizations that have several teams. Are you finding that it's better for those teams to have like their own area that they're responsible for in the system architecture, whether that be microservices or just an area of the code base versus another department? Or how have you seen that work well?
So in all cases where I've seen that work well, you have a pretty clear boundaries between the team, at least for the operational boundaries, where they do most of the work. But then, of course, you want each team's knowledge boundary to be slightly wider so that you're familiar with other parts of the systems and other teams, you know them as persons, which helps you minimize the risk for social biases. But I do try to avoid an overlap between different teams.
Interesting. I know that some organizations might have multiple teams. Some teams might be working on new features, and then there might be another team that's responsible for, say, ongoing support and maintenance of that work, maybe like providing like real-time customer support and, squashing bugs, and they might be overlapping on the same bit of code. Do you feel like that's an okay approach pattern to take?
Yeah, my personal perspective is I'm not a big fan of that separation. Because I think what it does is if you separate out maintenance work and bug fixes, you basically cut out an important feedback loop to the original developers. And if you look at it from the point of the software, it's really no difference why it's modified, if it's a new feature or if it's a bug fix. So I don't think it makes sense at all to separate that.
I've heard that some teams might have rotations or may not have that at all, or maybe that's like a way that they're just completely different teams there. So I'm always curious how different people kind of reflect on that or see if there's advantages to that or not. I agree that there's a necessity for making sure that developers that are working on features hopefully are more often than not getting some exposure to like how users are actually using the application and getting feedback and working through the issues that maybe that their work had contributed to. But I know that's not always the case in terms of there's like a factory belt, conveyor belt type of approach to a lot of organizations where things are coming through and kind of keep getting pushed out by different teams or something, but it's interesting. How do you define technical debt?
Oh, there are so many definitions of technical debt. I tend to use Martin Fowler's definition, but when I speak more freely about it, I typically use technical debt to reference any code that lacks in quality that has an impact on the business, code that we have to work with frequently.
So bad code or low quality code, how are you able to ascertain whether or not code is bad or not outside of it being a subjective opinion that you might have as a developer?
Oh, so there are definitely objective factors that tell you if code is good or not. And what I typically do is I look at how would our brain prefer to view the code? What kind of constructs put a heavy cognitive load on us? And that's actually a fairly well-researched topic. So just to give you some simple examples, you might have things like brain methods, where you have a method that tends to be central to a module or a class, and it's stuffed with a lot of complexity. And each time you touch that method or that class, you end up in that method. Or you might have things like deeply nested logic, which puts a horrible load on our working memory. And that kind of construct is responsible for roughly 20% of all defects. So I think it's fairly easy to identify bad code. I think the hard problem is to prioritize it. Which parts should we fix?
Maybe excluding yourself, what do you believe other software developers often get wrong when they're discussing technical debt?
So I think the single most common thing I've seen is that we tend to misuse the concept of technical debt in the industry. We basically claim that any code that's bad, it's technical debt. But it's not technical debt unless we have to pay interest on it, in my perspective.
And I hear people talk about, that the idea of there being interest and, I know that we're not technically making payments to some credit authority on that work. What are some ways that you've seen teams need to pay that off? Like what are some examples of that? Because I think there's this kind of it's an interesting concept that we talk about that and there being an interest percentage, but I think some people, myself included, sometimes struggle with well, what do you mean by interest then exactly if it's not technically interest?
Yeah, it's an interesting question because technical debt is notoriously hard to quantify, right? So that's why we often end up with these discussions. I haven't seen any approach to quantifying technical debt that kind of convinces me that this is the way to go. In theory, and what I often observe is that with a high degree of technical debt, you tend to see lots of effects on the product roadmap. You typically get longer lead times, and your end users are going to experience effects on the external quality. They're going to detect defects, and it's going to take a long time to fix them.
Interesting. Would you consider things like having your applications that say you're using some software frameworks or some libraries, open source libraries, what have you, and you're several versions behind? Would you consider that technical debt, or is that something else?
It could be technical debt. I mean, technical debt in the real sense of the word is that we have made a conscious decision not to update those libraries because we want to get something else out the door. But yes, in most cases, I would consider it technical debt, yes.
What are some examples of technical hurdles that you've had to climb over when you've been dealing with other or older code bases?
Oh, there are plenty of them. I think the number one challenge is to get a solid understanding of the domain. And I'm referring to both the problem domain, why are we building this stuff, how are the end users using it, but also to the solution domain, how is everything structured? What is a holistic overview of this code base? What does it look like? Those are my initial hurdles. And another thing that I frequently see is, of course, that the original developers are long gone, and there might be parts of the code that no one really has a good understanding of. And tests, of course, tends to be absent.
I've heard you talk or mention that you stopped doing TDD after about a decade of doing that. What prompted that?
Yeah, that's interesting. I used to be a big fan of TDD, and in a way I still am. I think it's a brilliant methodology, brilliant design technique. But basically what I found was that after using it for 10 years, mainly on object-oriented code, I became increasingly more interested in functional programming. And I actually found that when moving to functional programming, which I've been doing full-time for 5 years now, TDD actually got in the way, because functional programming has so short feedback loops. Right, you always have some interactive prompt, and since you don't have any side effects and no state mutations, it's so easy to just derive a small algorithm or a small function in the REPL. So that's what I tend to do, and then I tend to formalize them as test cases afterwards. So I turn it around a little bit.
Interesting. So you found that when you're working with more of an object-oriented environment, that TDD was more helpful for you?
It definitely was, and I actually think the biggest problem I have with TDD is actually the name. I don't like the emphasis on test, because to me the most important and valuable thing of TDD is the interactivity that it brings to traditionally non-interactive languages and environment. It's invaluable.
When you're working in object-oriented or any of these other platforms or approaches, did you ever kind of get into behavior development of BDD?
Oh yes, I tried it out. I find it valuable, and I tried it out a couple of years ago, back in my previous life as a software consultant. I tried to use this to communicate within teams and with project managers.
When you're talking a little bit more about like how you're interacting with the system, are you talking about different types of tests, maybe not on a unit level or something, or is it just you were just struggling with the concept that it was test focused primarily?
So I think with TDD, it's still valuable. If I were doing object-oriented programming, I would continue to use TDD. But in functional programming, I simply found that there's a quicker and simpler way that seems to work better for me.
Earlier, touching on things that teams or other developers sometimes get wrong when they're discussing technical debt. And you're talking about how, sometimes there's just bad code or maybe a difference of opinion there. Are there other ways you've seen teams like successfully take that technical debt and figure out a good way to prioritize how they're going to start approaching it?
Oh yeah, I have a number of good examples. What I think they all boil down to is that you need to have a really, really good understanding of domain. If you're a domain expert, that's where you can truly simplify. So I've seen large chunks of code removed, like hundreds of thousand lines of code, because with deep domain expertise, you can realize that, all right, this feature is actually no longer needed, or we can build it simpler. So I think domain expertise is the road to true simplifications.
You talk about like removing code and stuff. What's your take on, I'm assuming you have some experience working in and leaning on open source, like frameworks or libraries at times. Are you more of an advocate for taking advantage of those libraries that you can pull in and someone else is maintaining that part of it? Or do you tend to be more of an advocate for baking that your own version if you know that you can write it in much less code necessarily, but not need to rely on everything that other tool is providing you and then keeping it updated?
So I'm a big fan of libraries, and in general, I don't have a problem depending on a library. What I don't like is frameworks, because they tend to enforce a specific style on my application code. So I try to avoid frameworks.
And do you find that when you work with teams that do work with frameworks or don't work with frameworks, kind of in the difference there, I come from like a world where I've been working with a specific framework for a long time now. And one of the benefits I found is that I can reasonably expect most applications to follow some decent pattern that we can kind of know where things are going to go without having to figure out what was the style of that particular team that we were coming into. And so how have you found there to be good trade-offs to, not needing that sort of opinionated approach baked into a framework? Do you have your own strong opinions that you consistently kind of adhere to, or is it kind of on a project by project basis?
So I do have my opinions, and I've made that observation a few times that I think there's a reason that frameworks are popular, of course, because they do seem to simplify a number of tasks. I also found that one of the advantages with frameworks, which you touch upon, is that they give a kind of a predictable structure, right? You pick up a piece of code, you know approximately how it will look. And I think that's the good thing. The bad thing is that structure is not always what you want. And then it becomes incredibly hard to do something else.
So I think it could be a good time to talk a little bit about one of your books, Software Design X-Rays, where you write about using behavioral code analysis. For our listeners, what is behavioral code analysis?
Yeah, sure. So behavioral code analysis is where the emphasis is put more on the organization and the developers building and creating the source code than on the source code itself. So we use the behavior of the development organization as measured from version control data, project management data. We use that as a lens into the actual code. And it's something we use to prioritize technical depth or maybe reason about social factors of software development projects. So some examples on social might be low system mastery. You have a large knowledge gaps in your code base. Parts of the code written by the developers are no longer present, which is something that often makes the code really, really hard to evolve. Or it might be uncontrolled coordination needs between different developers in the code.
And so are you able to determine that by looking at, say, the history of certain areas of code base to figure out if there's only been certain people that have touched an area of code, and or if there's a lot of people that work in code, then you know that means there's an area that a lot of people have access to it and have some familiarity with it?
Yes. I mean, version control data is always a little bit noisy, but you can get very, very close to good answers. So if you look at the history, you can always figure out who the main developer is behind a piece of code. And if that person leaves, you might have a problem, depending on what that code looks like and how business critical it is.
What do you encourage teams to do at that point when they find that there is some areas of the code that are maybe some really complex area of the code that the developer is no longer there? Do you have some advice on how they sort of remedying that or figuring it out?
Yeah, I do. There are two things to it. The first is I think it's important to be aware of, because I've seen it so many times that I go and visit a development team and they find that they tell me that the code is incredibly hard to understand. And then you look at the code and it's actually not that bad, right? And then it turns out that that code is, of course, written by someone else. So we often mistake unfamiliarity for complexity. So just being aware of that is a very good first step. The second thing I would do is I would actively and regularly have a look at knowledge distribution as seen from the code and ensure we don't create too large and too serious knowledge islands. So I think being proactive is the best way of dealing with it. It's very hard to deal with in retrospect.
So part of that would be having teams, maybe when you're divvying up the type of work you're going to be working on in the near future, about where things are. Let's say you're working on a team and you have a product backlog that you're adding a bunch of new features, and there's one person that tends to keep working on one area of the code. Is a recommendation that you would have is that that team should actively plan to try to bring other people into that area of the code so there's more exposure to that versus like who's going to get it done the quickest?
I actually don't think there is an easy answer to that. I think there is a balance we have to find. So I think it's good in a sense that you have a person who's motivated to work with a specific part of the code who can build expertise in that area. That's valuable. But you do want to get other people into that part of the code too. If nothing else, then for that single expert, because it's not a fun position to be in because you can never go on vacation after that, right?
Right. It's something that I notice in different teams as well, just where there's a tendency, I think, because there's a lot of other constraints like time constraints on getting things done, different projects, and there's this kind of gravitational thing that kind of happens where, well, I'll take that on because I know that area inside and out. And so it'll just be quicker for us as a team if I take care of it. It's not necessarily a problem, but it does create a weird compounding problem over a period of time where that keeps happening over and over, where the same people tend to keep working in the same area because they understand it. And then the teams kind of grow and there's a pain point that they're not really addressing. And so it's interesting that there's ways to do that with tools to help highlight that as well, because I think on a kind of base level in teams, they probably know people could probably identify that if you ask them and to think about those, like which area of the code base do you primarily take care of more than anyone else? But I think there's also that challenge when people leave, and then there's the, oh shit, what are we going to do the next several weeks before they go? How do we make sure that there's a knowledge transfer from that person or something? And you're never going to get everything out of that process either. And so there's always it can be a little difficult to transfer that knowledge from one brain to another, for sure. So kind of touching back a little bit more on your book, what inspired you to write the book in the first place?
Oh, so Software Design X-Rays is my second book. The previous one was Your Code is a Crime Scene, and Software Design X-Rays follows in that book's tracks. So it's like a reflection of what I learned between the two books. But they cover similar ground. And what I did with Your Code is a Crime Scene was basically that I wanted to capture and share a number of techniques that I have been using myself successfully in my consulting career. So that was my initial motivation. And with Software Design X-Rays, I wanted to reflect what I've learned in the years between the books.
And are these like a lot of patterns for how you're approaching things in existing applications and how to improve the software itself, or at least to help you understand the software, or a bit of both?
So I'm trying to send a positive message. So it's mostly about you have this existing code base. How can you make it easier and cheaper to maintain it? How can you lower the risk? That's the overall theme throughout the books.
Of those different patterns and techniques that you have, is there something that you find yourself, pattern that you find yourself deploying most often when you're talking with different teams?
Yeah, definitely. There are a bunch of patterns I use more often. So one of the most important techniques that I share in those books is a concept I call hotspots. So hotspot is a technique that helps us identify complicated code that we have to work with often. And that's typically expensive code, right? And the interesting thing with the hotspots is that I have lots and lots of data that shows that given any kind of application, you can basically narrow the hotspots down to maybe 2-3% of the total code base. So for me too, that's a positive message. It basically means, no, you don't have to rewrite those 2 million lines of code. It's enough to focus on this small percent.
Nice. I'm going to touch a little bit on rewrites in a bit before we get to that. Your company, Empear, has also released it CodeScene. What prompted you and your team to begin building it?
Oh yeah, I didn't plan it initially. Thing was that after I'd written Your Code as a Crime Scene, I'd started to attend development conferences and I became a public speaker. Many people were very encouraging and were interested in the techniques from Your Code as a Crime Scene. And I kind of realized that at this point, I've really just scratched the surface of what's possible. And to make these techniques mainstream, there has to be good tooling support around it. So that was basically the point where I decided to quit my safe and well-paid job as a software consultant and jump on the startup train, which I did with Empear and CodeScene.
Nice. And I was taking a quick look at CodeScene in preparing for this conversation, and you had some open source frameworks and stuff as an example, so you can kind of click around. And I was looking at some of the details related to like the Ruby on Rails project as an example. If a team were to be interested in using a tool like CodeScene, what sort of information would your system need to collect? Is that just access to the repository, like a Git repository, version control of some sort, or do you need other information like from a production environment?
So it's a little bit different because we actually have two versions of CodeScene, right? We have the public cloud version and then we have an on-prem version. So larger companies, they tend to use the on-premises version, so all data stays on their servers. But what CodeScene needs is basically it needs to be pointed to one or more Git repositories, and that's it.
And so it's kind of like keeping an eye and pulling in details on like the history of the project in terms of from like a Git repository perspective. And so kind of helping teams understand, you touch on things like churn earlier as an example. For those listening, what is churn in a code base?
So churn is basically the rate of change of a piece of code. And the more frequently it's changed, the more important that piece of code has a really high quality. Any quality issues in a hotspot are going to be expensive.
Is this information targeting specifically like the software developers on the team themselves, or is it more of like for like team leads or engineering managers or someone in more of a management type role to get like a holistic view of things?
So I do think that our typical user are tech leads, architects, technical managers. But I have used the techniques myself with many teams for onboarding, for example, because visualizing software, in a way, it makes it tangible, right? It really helps in building a mental model. So I'm a big fan of visualizations.
That's interesting. You're touching on onboarding, and when a new engineer joins a team, I'm sure that there's a lot of different ways that teams might consider bringing them and showing them around the code base, giving them that tour, whether that be through code or looking at some of their tools like this, or maybe they're just getting an invite to a repository and saying, take a look at this for the next few days and we'll talk about, your first assignment or something. Are you finding that teams can provide them access to this information and kind of this helps provide some of that analysis? Does this still require probably someone to sit down and kind of explain to them what they're looking at, or what have you seen in that type of scenario?
So I think a very brief explanation, like that's the way I prefer it, because I do services for different organizations where I help them out prioritizing technical depth. So I do lots of onboardings myself, maybe 10, 15 of them each year, right? The way I prefer it is to just get the visualizations up in CodeScene, drill around, find the important parts of the code base, and then I'm all set for specific questions to the existing development team. It makes it so much more effective, in my opinion.
I'm assuming there might be some open source tools that can provide some of this data somehow for folks.
Yes, we actually made CodeScene free for open source. So if you work in that space, you can just check it out. Previously, I open sourced my first versions of the very early tools I did, like 10 years ago. So they're open sourced on my GitHub page. They're a bit limited, but they might be a very good starting point if you want to play around with this.
Yeah, I would be also curious for those listening that if you're a developer that's maybe starting a new job soon and that team doesn't have tools like this in place, tools like this could be a good way for you to better understand, hopefully helping speed up the process of getting a mental model of that infrastructure there. It's interesting as someone that hires developers, I haven't seen anyone come in and bring in some tools themselves to say, hey, look, I'm figuring some stuff out, and be like, oh, wow, that's that would be great. Versus like, all right, show me around the code base is a different type of conversation than look what I've already discovered by running some of these tools on your system, because not all the teams maybe prioritize spending time on analyzing this stuff as much as they should be.
Yeah. I also have a very good experience using similar onboardings for test people, right? So I used to work a lot with skilled testers previously, and one of their challenges in a large organization is that when things go south, you find a bug or something, you have no idea who you should talk to. It's really, really hard. You might know in which part of the code it is, but you don't know who actually wrote it. So in CodeScene, you have stuff like knowledge maps. So you have a map of the code base, you know who the main developers are, and it really, really helps you to find the right person to talk to.
That's great. What types of services does Empear offer? You touched a little bit on working with companies and their teams. Can you touch on that a little bit?
Yeah, sure, definitely. Empear is primarily a product company. The reason we do services is because we are a bootstrapped startup, so we never took any venture capital. We bootstrapped it by doing services on top of CodeScene while we were developing the product. So we do services where we help you prioritize technical debt. We do workshops around paying down technical debt, around refactorings. And we have continued to do that because I find it's an excellent way of being primary user of our own tools, of eating our own dog food all the time. It's so valuable.
We've all heard about failed and or drastically underestimated rewrite projects, but I'm curious if you've had experiences working on a successful rewrite.
Yes, and my sample size, it's limited to one, but it was a big one. So I'm normally not a fan of rewrites, but what happened here, this is like 15 years ago. I worked in a large product company at that time, and we had this system. It was 10 years old. It was written in a proprietary 4th generation programming language that no one understood. I was unfortunate enough to have learned a little bit of it in school, so I was put on maintaining that system, right? And we were looking to expand the feature set heavily, and we just realized we cannot squeeze that into the existing application within the allocated time. So we embarked on a rewrite, and it was pretty interesting because this is 15 years ago. But what we did was basically we took the Unix principles and applied them at the architecture level. Yeah, it basically led us all the way to microservices, although we didn't know that term existed back then, of course. But I can talk a lot about that project.
What are some of those Unix principles for those that might not be familiar with that on the lower level?
The guiding principle for us was that we wanted to have it very, very modular. Instead of writing one big system, we wanted to have many small systems, and each one of them doing one thing well. We wanted to have them extremely loosely coupled so that we can glue them together in any kind of configuration we wanted. And that kind of led us to a service-based approach with message-oriented middleware connecting all of them and completely decoupled.
Do you find that there was some other aspects to how the team organized that work that helped make that team more successful at going through a rewrite versus necessarily on the technical side itself?
So I think the main reason we managed to pull that off didn't have much to do with technology, but it was due to the fact that the two of us who were leading that effort, both of us had the experience maintaining the previous code base. So we knew about all those implicit requirements that you always miss otherwise. We were well aware of them. We had also been doing some support directly to customers. So we knew that one of the reasons that the previous code base is incredibly complex is because that system had a crazy amount of configurability. Each customer were using it in different ways, and we kind of realized that that's what we need to rip apart. So that's what led us down that path. And without that experience of maintaining the previous application, I'm pretty sure we would have underestimated effort.
Interesting. I hear people talk about sometimes that sometimes they come into an environment where they're inheriting some code. And it's safe to assume that it sounded like you were also in a similar scenario where you came in and you inherited some existing proprietary system code. How did you go about proposing or getting to a point to convince the stakeholders or pitch the idea that they should invest in a rewrite in the first place?
Oh, it was actually interesting enough. It was a very easy sell. So I was actually asked about proposing two options, either expanding the existing system, what would the trade-offs be, how much would it cost, versus is it doable to rewrite the whole thing, What would that cost us? What are the risks? So yeah, that's what I did. And for once, I made the right choice.
Nice. I want to quickly circle back to technical debt. Let's assume that there's a few listeners out there who find themselves with a large list of what their team has identified or is calling technical debt. Perhaps they're feeling a little overwhelmed by the amount of work ahead of them and are finding it really challenging to just figure out how to prioritize that work. What advice can you offer them on how to begin prioritizing a big body of work like that?
So my first advice is to start really simple. Just prioritize the most complex modules that you have to work with often. So a simple hotspot analysis helps you get started. It takes that huge amount of code and narrows it down to very few problems. From there, you can actually dig even deeper. With slightly more advanced analysis, you can actually get hotspots down to a function level, and then you can get started and get some really quick wins within just a matter of days. And I would also recommend to do those initial refactorings using techniques like mob refactoring, because that's going to help you to spread the knowledge of how do we attack these kind of problems. And you're going to get everyone to align upon a common and successful approach, which I think is important as well.
And so is that the kind of the approach where you get multiple people working together in a mob pairing type of a scenario on that specific area of code?
Yeah, and I think it's really very valuable when we're factoring legacy code, right? Because you want to ensure that the new code is better, for some definition of better than the previous one. And that's why I think it makes a lot of sense to have a group doing that. So it's clear that it's everyone's responsibility, not just one lead developer who does a one-off refactoring.
Right. Do you think for those that are listening who might have a process where people, maybe they go through pull requests, do you feel like that's sufficient enough of a review process to have if you have one main developer working on sim refactoring and they pass it off to someone else or other people on the team to review their code? Do you feel like that's like almost as valuable, or do you really encourage people to like kind of team up on that when they actually do the refactoring itself?
I think it's valuable to team up, at least initially, right? Because it's about learning from each other. I think it's really important. I don't think you can replace it with pull requests.
Yeah, I'm always curious how difficult it can be for teams to, given all the information that's coming through them, when they get a pull request of like a pretty large, substantial change. How do you go through that and really like understand when you're just looking at a diff or something like that in your browser or something to really get a good feel for how things have changed unless there's a really good pull request process that your team has in terms of like outlining what you've done and how you've kind of approached it, showing that your tests are still passing or what have you. I just think that doesn't seem like it's the same as sitting down and talking through it together, whether it's in person or remotely or whatever. I kind of cite on that mob side as well too. But teams are looking at this big list of technical debt, and you're touching on some areas where they can start. What about when they bring in an external team or a couple developers to help them on, like if they bring in a team like Empear to help them working on that technical debt? I'm sure if you get down to that level or not, or if you're just helping them prioritizing and coaching them on to help take care of themselves. But when they do bring in external resources, because maybe they're just feeling like their backlog is growing too quick, and so they bring in an external developer, do you find that it's still similar types of areas of the code that you would encourage someone new to the code to first jump into? Or would you prioritize that a little bit differently for that external person that's new?
That's an interesting question. I don't think I've seen that exact scenario. What I would be worried about myself, if I was in that situation, was to let someone new touch the most critical parts of the code without knowing where the code came from. I would actually prefer to have a group of people work on that. I think there's value to bringing someone external in, because the external person typically doesn't know about the internal politics on the organization. They don't have anything invested in any part of the solution, and it's more likely that they can be objective.
Part of the reason I was asking that is because, my company does, we come in and help teams with their backlogs and stuff in a similar way, but we usually get pulled in. And it's interesting how there's some teams that they like earmark certain things, like, it'd be amazing if we could just have these new developers that aren't, as you said, super embedded into our team's organization and our internal politics and all the other things that have been happening over here. I don't have time to think about this really complex thing, but then they want to bring in someone external to come in and help them with that. As a software consultant on my end, those are like the most daunting and scariest things to first come into. You're like, I don't want to be responsible for this really critical part of your application yet, because I think I would much rather start on some smaller things so we can show that we work well together. And start to learn about your system, but don't throw us into the deep end of this big scary thing because your team you don't have the time to work on it yourself necessarily. And usually in that scenario, they often don't have the time to really explain it to someone new either. So it's kind of like becomes like a similar issue. It's not like you can just go in and jump into code, even if you're using a framework and know like that big nasty hotspot area of the code base is going to be something that you can be super successful at. Anyway, that's kind of what I was curious about that to see if you've seen that work well, because I always have a little bit of a fear when a client asks us to kind of start in those areas. We'll be back with our interview with Adam in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to thank you, yes, you, for making time to listen to Maintainable. If you're finding these conversations valuable, please consider sharing a link amongst your peers on social media like LinkedIn or Twitter or Facebook or TikTok or wherever you folks are hanging out these days. And or maybe even consider writing a review on Apple Podcasts or Stitcher. Also, if you know someone in our industry who I should be speaking with on Maintainable, shoot me an email at robby@maintainable.fm. And now, back to our interview with Adam Tornhill. We're talking a little bit about how teams have their different knowledge boundaries. And, we talked about developers should also probably work more on the front lines of providing support to the work that they've recently worked on, like new features and such. Are there some other patterns you've seen teams work well on sharing and communicating what their other teams are focused on? And so that there is a little bit more of that knowledge transfer, even if they're on different teams. Have you seen some good patterns for how teams can share and disseminate, like so that they understand what the other team's focusing on and where there might be some overlap there?
So I have to say that there are basically three things that I've seen works well in real life. The first one is to kind of make it a habit. If you do formal things like pull request reviews or code reviews, make sure to invite a member from a different team to them. It really helps you not only make personal connections to the different teams, but you might also get an outside perspective. The second thing I've seen work well is when you encourage, don't enforce, but encourage people to rotate teams. I also think that's valuable because it builds on the intrinsic motivation of individuals. And then I've seen some organizations, large organizations, that are fairly successful with an open source inspired ownership model. So that could also work well.
What would that look like, an open source ownership model?
So it would basically mean that you have a team, and I think the key is to have a really small team. And with small team, I mean maybe 3, 4, maximum 5 people. And you have them actually being responsible for a piece of code. Anyone can make changes to it. And if you do the changes well enough, the team will accept your pull request. So it kind of takes away the risk that the team becomes a bottleneck with work queued up. If you do the work yourself, you do it well, you can have it quickly. So I'm a big fan of that model.
What types of documentation do you find most valuable as a consultant, say, coming into organizations to help you understand their system? Or is there supporting documentation? If like a team doesn't have a lot of thorough documentation, if there's a type of documentation that you find most valuable to newcomers, what would you say that might be?
So I would say my personal favorite, and this is a rare thing that I find it, but my personal favorite is when overall architectural and design principles are documented. Because to me, that's one of the most valuable things.
What sort of questions would that help you at least answer for yourself?
It would definitely help me navigate the whole system and the whole code base. And it would also help me understand why things are the way they are. That would be very useful to me. I'm not a big fan of lower level documentation. I would also appreciate some kind of getting started guide. Ideally, as much of it as possible automated, so I don't have to do so much. So I can quickly get in and start to do some productive work on day one. It's something I've always appreciated, and it doesn't happen often.
We see projects sometimes where it'll have like a single script that gets everything set up, or at least telling you all the dependencies you need to get running, versus here's a checklist of 8 to 20 things you need to do, and please follow this order and everything should work. What would you say the success rate on those types of scenarios is for you?
Oh, it's been very low in my career, unfortunately.
Why do you think that is?
I think it's because no one is responsible for it, really. I think it's often becomes a collective ownership, those onboarding guides, and no one has to live with them, right? Once you get through it, you don't no longer need it, which means you don't care so much about it. I think that's the reason.
It's a thing that I sometimes been asking different developers, like how anxious would you be if I said you had to get a new laptop tomorrow and start setting up your environment again to work on this application. How anxious would you be about getting everything running again? And when's the last time you tested your getting started documentation? And nobody wants to go back and do that very often. And then I think there's always this idea that you just kind of pass it on to the next person that's going to come through and they'll help clean it up. But I know it's been my experience that a lot of the time when you're doing that, you hit these weird things that weren't documented, and you have to go off and figure out some dependency stuff. You fix that and you're like, well, maybe that was a one-off issue just for me. So I don't know if I need to actually go update the documentation itself. So I think it's a tricky one. Well, I think it's a few quick last things I wanted to touch on with you here. And so if people wanted to learn more about CodeScene, where can they find out more information?
So the best way would probably be to look at our interactive showcases on codescene.io. That's usually a fun way to get started. You can also check out my company blog at Empear.com, where I have lots of case studies and write about this stuff in more depth.
That's great. What non-software development book do you find yourself most often recommending to people in our industry?
Non-software development book. Wow, I read lots of strange stuff. To recommend one book, I'm a big fan of Zen and the Art of Motorcycle Maintenance.
Nice.
Big fan of it.
It's been on my bookshelf for probably a decade and a half, and I've never started reading it. It's one of those things where everybody talks about it, and then I've never just picked it up and started reading it since I picked it up at the bookstore. So I might need to do that. I know you mentioned the Empear blog, and where else can people follow you online in terms of following what you're up to or where you're going to be speaking at?
Yeah, so I'm Adam Tornhill on Twitter. I tweet regularly. I also have my personal blog at adamtornhill.com, where I publish articles, book reviews, and occasional talk.
Excellent. Well, it's been such a delight having you on Maintainable, Adam. Thanks so much for joining us.
Yeah, thanks for having me. My pleasure. Thank you.
Maintainable.